Okay, so if you're into anime, you know Saitama, the One Punch Man. The guy's a legend for one simple reason. He can end any fight with a single reality-breaking punch. It's awesome, it's hilarious, and it's completely impossible. And that's the big question we're digging into right here. Let's just push anime logic aside for a second. What if a regular person, made of normal flesh and bone, tried to throw a punch with that much power? What would the laws of physics do? Not to the bad guy, but to the person throwing the punch. Well, the answer is pretty explosive. Let's get into the science of why. All right, to really wrap our heads around this, we need to grab our physics toolkit. We've got to understand the basic rules that control every single impact, whether it's a little tap on the shoulder or a punch that can crack a planet. And it all boils down to one key idea. And that idea is shock. Now, in physics, shock has nothing to do with being surprised. It's all about speed and time. It's what happens when you get a massive, massive change in velocity in an incredibly tiny window of time. You could say Saitama's punch is the poster child for physical shock. So to get the force behind that shock, first we got to talk about momentum. Think of it this way. Every single thing that's moving has momentum. You get it by taking its mass and multiplying it by its velocity. Now, Saitama's fist, it has the mass of a normal human fist, but its velocity is just off the charts, giving it an absolutely insane amount of momentum. So how do you actually deliver all that momentum? That's where impulse comes in. Impulse is the force you apply times how long you apply for. To change something's momentum almost instantly, the way Saitama does, you have two options. Apply a small force for a really long time, or apply a colossal, unbelievable force in a fraction of a second. Guess which one Saitama's punch does? And this brings us right to the heart of it all, Newton's second law. Force equals mass times acceleration. To get the kind of force you need to vaporize a monster, Saitama's fist has to accelerate at a rate that's it's hard to even imagine. But here is the most important part. For every action, there's an equal and opposite reaction. That force isn't just blasting outwards, it's blasting right back into his own body. So, we have the physics of the punch, right? An unimaginable force firing back at the user. Now let's look at the other side of the equation, the incredibly fragile biology of the puncher. Because a human body, unlike Saitama's, has limits. Very clear and very, very unforgiving limits. Just think about G-forces for a second. A Top Gun fighter pilot wearing a high-tech compression suit can maybe handle about 9 Gs, 9 times the force of gravity, before they black out. The acceleration from Saitama's punch? We're talking G-forces thousands, maybe even millions of times greater than that. Our bodies just aren't built for that, not even close. See, every material in the universe has a breaking point. It's called its ultimate strength, and that includes our bones. Your femur, which is one of the strongest bones in your whole body, can take about 150 megapascals of pressure. That sounds like a lot, right? But compared to the forces we're talking about with this punch, it might as well be a piece of paper trying to stop a bullet. And you gotta remember, the bones are the strongest parts we have. The muscles creating the force, the tendons connecting everything, and especially our soft, squishy internal organs, they are so much weaker. Their breaking point is way, way lower. The body is a whole system, and it's only as strong as its weakest link. Okay, so let's do it. Let's run the thought experiment. A normal human body, right here in our world, tries to throw a serious punch. What happens in that split second? Well, what happens is a catastrophic chain reaction inside the body itself. The very instant those muscles contract with that impossible power, the whole system just starts to fail. The force yanks on the tendons and they shred like tissue paper. The remaining force slams into the bones of the arm, which instantly shatter because they're pushed way past their ultimate strength. And this brutal shockwave doesn't just stop in the arm. Oh no, it keeps going right through the rest of the body. And this is where it gets really gnarly. Because of inertia, when your skeleton suddenly rockets forward at that unbelievable speed, your internal organs kind of lag behind for a microsecond. They don't move at the exact same time. And that tiny difference in movement creates what are called shearing forces, which would literally rip your organs apart from the inside. So, this brings us to the grand finale of our little physics investigation. We've looked at the insane forces of the punch, and we've looked at the very real limits of the human body. When you smash those two things together, the result is as predictable as it is dramatic. The biomechanical result is just total system failure. The bones don't just break. They basically pulverize into a fine powder. The muscles and tendons are shredded into nothing. The internal organs are ruptured from those shearing forces. In that one instant, the entire body loses all of its structural integrity.
To put it as simply as possible, the puncher would be completely destroyed by their own punch, long before their fist ever even reached the target. We're not talking about a broken arm here. We're talking about the complete and utter disintegration of the biological machine trying to throw the punch.
So, obviously, the big question is, why doesn't this happen to Saitama? And the answer is super simple. He gets to play by a different set of rules, the wonderful, unbreakable rules of fiction. In the One Punch Man universe, we just have to assume a few things. First, Saitama's body isn't just strong, it's basically made of some kind of unobtainium, a material with a nearly infinite ultimate strength. The show runs on its own laws of physics, where the rule of cool and the need for a good punchline are way more important than the laws of thermodynamics. The whole point is that over-the-top, hilarious exaggeration of his power. And that leaves us with a really fun final thought. Saitama is just one guy. Once you start applying real-world physics to superheroes and anime characters, you find these self-destructive paradoxes everywhere. So what other fictional power from what other character do you think would just completely annihilate its user if they tried it in our world? It's a fun and maybe a little terrifying thing to think about.